That's fun.
Oh, thank you. So can you hear me okay? Yeah? Great. Okay. So we're going to talk about collecting, combining, and caching RxJS streams. And I have a link to the slides and the code at the end, so you don't have to be trying to write down what you're seeing. My name's Deborah Kurata, in case you didn't get that from the beginning. I'm a software developer. I'm a consultant. I'm also a Pluralsight author, a Microsoft MVP, and a Google GDE. So that's pretty exciting. So we're going to merge our streams here this morning, this afternoon, this evening, whatever time of the day it is. I don't know. It's like 9 o'clock in the morning. So what we're going to do is we're going to look at a declarative approach for collecting, combining, and caching our streams with RxJS. And the important part is that we're going to do it with no subscriptions. And the best part about no subscribe is no unsubscribe. That's exactly right. So you don't have to have some kind of complicated code to make sure you're unsubscribing from everything. So we're going to take a look at how we can go ahead and do that. All right, so our sample application is pretty simple because we really want to focus on the code. So on the left-hand side, we've got a way to display a list of things. The user can pick something from the left-hand side, and it displays the detail on the right. Relatively straightforward. So that's kind of the app we're going to be looking at for this talk. So we talked about the fact that we're going to look at collecting, combining, and caching. So this is our collecting. Now, we've probably all learned our current pattern for retrieving data, right? We have some kind of get method and a service. So here's my product service with a get method. It is simply returning the result of an HTTP GET request. And in our component, we have implementing on init and then writing our ng on init that calls this. We dump it into an array of some kind and bind to that array. Okay, so we're all familiar with this pattern, yeah? I know that's what I teach in my intro courses, and it's probably what you learned. That's how they show you in the documentation and everything. That's how you retrieve data. But I'm going to propose a different approach, and that is a more declarative pattern for retrieving data. So instead of defining a method for retrieving our data, we're going to simply define a property. So we have product's$, and the convention is to define an observable with $1 at the end so that you know you're working with observables. And instead of then having a method, we're going to simply assign the result of our HTTP GET directly to this property. Okay? Does that make sense so far? And we've got a little bit of error handling there. All right, so what does that mean for our component? Well, in our component then, we don't need to implement on init. We don't need ng on init. We don't need procedural code in here. We just define another local property in our component and assign it to the property from our service. Easy enough again so far, right? Even at 6:10 in the evening. Or no, let's see, 6 and 12, 18, 18:10. Okay, so now that we have a product's$ here in our component, we're going to have to bind to that instead of our products array. So we do that using the async pipe. So the async pipe does several things for us. First of all, it automatically subscribes when the template is loaded, and it automatically unsubscribes when we leave the component, when the component is destroyed. In between times, once it is subscribed, what it does is it loads the result every time the observable emits something, it loads it into the variable. So that's what that as syntax is doing. By saying as products, every time that stream emits something, it's assigned to that variable. Then we can use that variable anywhere else in our template. So it makes the rest of our bindings sort of look like we just had bound to our regular array. So far we're not talking about anything, really complicated, right? Why? Why would we want to do this? Well, one reason is we can then use on-push change detection. So if you want to improve the performance of your application by using onPush, you can do that by simply moving to this technique. Why does that work? Well, the onPush change detection minimizes the change detection cycles. With onPush, it will check for changes anytime one of three things occurs. One of your nested components has an input property that changes, when it has an output property that's emitting an event, and the third one, which is the one important for our case, when it's bound to an observable. And now we're binding to our observable stream, so we can be using our onPush change detection. So we get better performance. So using more declarative, more reactive, it gives us improved change detection. Maybe that's not enough. Maybe the performance isn't that big of a deal. Why else would we want to use this technique for managing our streams? Another reason is we can leverage more thoroughly the RxJS operators. At last count, there were 104. I don't know if anyone's counted them recently to know if there are more than that, but there are 104 different operators. You can do everything from accumulating information to filtering to all sorts of different things with these operators. You can also compose your streams, and we'll see how to do that here in a moment. Basically, what I mean by that is sometimes our user interface needs data from multiple sources, and we can combine all of those together. And lastly, we can better react to user actions. So as the user is doing something, clicking on things, whatever, we can more easily react. And we're going to see how to do that as well. Okay, so that was collecting. So we've got our collecting of our data. We now have streams all the way from our service through our component to our template. How do we then deal with combining our stream with other streams, and how do we work with that? All right, so come to find out, when we get our product data, we're getting the category as an ID number. So our API endpoint that we're calling to get our product data is giving us category ID 3 or 17 or 45 or whatever. And we could just display that to the user, and the user can go, I don't know what a category 3 is, right? What we really want to do is give them the category, the name. So how do we go about doing that? So we want it to be something like toolbox or garden or games or whatever our correct category is to be more user-friendly. Well, we happen to know we have another endpoint that gives us a lookup table, and we can find that category lookup table that has our IDs with our names. So we can declaratively define the category stream. So again, this is code just like our products dollar code, only now we're getting products categories. We're getting calling a different endpoint, but again, it's a declaratively defined stream. Okay, we good? Yeah. All righty. So then what do we do? Then we need to merge our streams, and there are several different operators that we can use with RxJS in order to merge our streams together. The one that I like for this kind of stuff is combineLatest. CombineLatest is actually a creation function, so you don't have to pipe it into something, have something, and pipe through something. You can use it as a static function and just call it and pass in the streams you want to combine. Now, in this particular example, I'm only combining 2, but you can combine any number of streams. We'll see another example in a few minutes that I'm combining 3, but again, it can be any number. So what does combineLatest do? Well, it combines multiple streams into one stream. That sounds pretty obvious. But it has a couple of specific things that it does. First of all, it uses the last emitted value from each stream, and it also waits for each stream to at least emit once before it emits. And as we all know, an HTTP GET is a one and done, right? It returns your data and completes. So this combineLatest will actually wait for both sets of data to be returned before it moves on. So that's a good thing, right? Because we don't want to try to match up products and categories when we don't have the products and the categories yet. So this will wait for both of them to complete. Now, When products dollar, when that stream emits, it's getting an array of products. When product categories emits and gets the data back from the HTTP call, it's going to give us a array of categories, product categories. And what combineLatest emits is an array with the result of each of the streams. So the first element in the array is the result of the first item, the first stream that we passed in. The second element in the array is the result of the second stream we passed in. Are we good with that? Yeah, okay. So you can kind of think of this as almost like a method, right? We need both bits of data passed into our method in order to be able to manipulate them and do the lookup and have to work with them. So you can kind of think of combineLatest as a way to pass in a bunch of stuff that you can work with together. Is that making sense? Okay, so our combineLatest is going to emit then this array. So what we can do then is map that data so that we can do this lookup. So the first thing I'm doing here is using array destructuring to assign a variable name to each element of the array, because it's easier than using the array syntax. What is array 0 versus array 1? What does that mean? Here I can actually give them variable names. Then I am using the products array that this is giving me back, and I'm using the array map function to map each product in that array. What am I doing with each product in the array? I'm copying it using my, that's the array map method. I'm copying it using the spread operator. So I start with a product, I create a new product that's a copy of the old one, and then add another property to it. So I'm defining this new category name property. I just called it category so it fit on the slide better, but that's our category name. And I'm using the second array that was passed in, that categories array, to find the right name based on the ID that I have. Seems pretty straightforward. Now, the last important thing is to define the resulting type. If you don't add the as product, if you hover over the result of products with category, it will tell you it is of type curly brace, property, 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 property. And we don't want that. Right? We want, coming out of this thing, a product array. So by saying as product, as it's mapping each of these products in the product array, you will end up emitting from this whole thing, and you'll have an observable that emits a product array, which is what your component is expecting to get. But now it just has an additional property. Is that making sense? Okay. So our component, remember when we looked at our component before, we were setting products dollar equal to this.productService.products dollar. Now we're going to instead set it equal to this.productService.products with category dollar. So now it just has our same product data, but now has this additional category property on it. Since we still have products dollar there on the left, our binding all still works. All we have to do in our UI is add or change where it was displaying category ID to display the category name instead. So what we end up with is a much more user-friendly display. And we don't have a lot of procedural logic going on. This is all just done with our streams. Okay. What if you need to combine nested observables? So the first question here is, what do we mean by nested observables? In this case, we have suppliers that we're showing in addition to our products. So with our product data is coming some supplier IDs. So supplier ID 7 and 15 or whatever. But we don't want to show the user, hey, supplier 15 and 25 or whatever. We want to show the actual list of suppliers. Now, the same thing would be true with customers and invoices, orders and order line items, any kind of related data like that. So how do we deal with that? Well, nested subscriptions are kind of the anti-pattern, which you're not supposed to do. So this would be code that we might have done earlier, where I am getting the product, I am mapping it to pull the supplier IDs out, And then for each supplier ID, I'm doing another HTTP GET to get that supplier, and then I've got multiple nested subscribes in here. You see I've got the subscribe and another subscribe. So that's an anti-pattern. It's not something that's recommended because of the complex nature of having them inside each other, plus you lose your stream going to your UI at this point. So what do you do instead? Well, you can use the higher order mapping operators, and I'm going to be looking at 3 of them. The first one is concatMap, and I've got a little thank you here on the bottom. So I just kind of simplified the example to demonstrate it here. When you think of concatMap, think of weighting. So concatMap weights. What does that mean? Well, I'm doing of 15 and 42, so this is just kind of simplifying the example, saying I have supplier ID 15, supplier ID 42. I can use concatMap to do the getting, and what will happen is when 15 is emitted, it will go get the data for supplier 15. When 42 is emitted, it's going to just sit there and wait. Once 15 is retrieved, then it will go get the data for 42. So it's going to do them sequentially, and then you will always be sure that your data is emitted sequentially. And oops, I just saw a typo on my slide. That should be an S over there next to my 42. Anyway, okay, so that's concatMap. The difference between that and mergeMap is that mergeMap runs in parallel. So if I do an of 15 and 42, 15 will start as soon as 42 is emitted. That retrieve will start, and it will get them immediately as soon as it can. It may give them to you then in order, or it may be out of sequence depending upon whether one call was potentially faster than the other. So you can't be guaranteed a sequence here. Now, of those 2, for our scenario, which one makes sense? I want to get all the suppliers for a product. Do I want mergeMap or do I want concatMap? MergeMap, because there's no reason I worry about sequence. I don't care about the order, so I don't need concatMap. concatMap is best for things when you do want to ensure they're done in sequence. Like say I was doing deletes instead of retrieves, or updates. I might want to ensure that they're done in order so that my updates don't go out of order and potentially mess up something or my deletes. mergeMap is best to do when you don't care about the order. I might, in my code, have my own pipe to sort it by alphabetically or whatever, so I don't care what order that these suppliers are coming back in. The last one is switchMap, and switchMap always switches to the most recent one. So again, I have of 15 and 42. When 15 is emitted, it goes to get 15, and before it's gotten it, 42 comes along and says, oh, okay, never mind on the 15, I'm going to go get the 42 instead. And again, this one would not work for our scenario. This is better for things like type ahead, like the user's typing, and every time they type something else, you want to re-get and basically forget about what had already been started. It's also useful when you're handling the click on the left-hand list. I clicked on the first one. No, I meant the third one, so that it just processes the last one that they've picked. Okay, so those are the 3 to help you deal with kind of nested information. So what we end up with then is our suppliers here on the bottom. Okay, so one of the other things we haven't talked about too much yet is actually reacting to user actions. So here, when the user clicks on the left on the hammer, we display the details on the right-hand side. So how do we make that work? We want to be able to have our streams react to user actions without having to write too many procedures to make all of that work. So how do we do that? Well, I've basically defined 3 steps in order to have our streams react to actions. So the first step is to create a stream that I've been calling an action stream. I got help on Twitter. I don't know how many of you saw that tweet stream on there. I was coming up with a bunch of different names, and we kind of settled on an action stream. Then combining our action stream with our data stream, and then lastly, emitting a value to the action stream every time an action occurs. That was kind of a logical name. I'm glad someone suggested it. Okay, so those are our 3 steps. So let's try them out. We're going to start by creating an action stream. How do we create an action stream? Well, there are numerous ways to create a stream, but what you'll frequently see for action streams is using subject or behavior subject. Subject is a special kind of an observable. A behavior subject is a special kind of subject. The key difference between a subject and a behavior subject is the behavior subject has a default value. So if I was creating a new behavior subject, I would have to be passing something into the constructor. So if your action stream requires that there be an initial action before any other real actions occur, some kind of initial value, then you want to use behavior subject instead. Okay, so you have the ability to create the new subject or the new behavior subject, and you can use the generic syntax to specify the type that you want. Now, in our case, the user is picking a product on the left, and what we want is we want that product's ID. So we're going to define our stream as a number. So every time the user picks one, we want the number, the ID of that particular product that they've picked, so that we can go display that on the right-hand side. Now, how is a subject and behavior subject different from an observable? Well, first of all, they're multicast, so they can cast to multiple subscribers. Normally, your observers are all unicast. So if you subscribe, then you get the results, and that's it. So that would be, instead of me talking to each of you, I'm going to call each of you individually and tell you my talk, which is not very efficient. We instead want to broadcast it out to everyone all at the same time. The other thing that's different about a subject behavior subject than an observable is the fact that a subject and behavior subject behave both like an observable. You can actually get at its observable with as observable, but also as an observer. And an observer is basically a object with next, error, and complete methods in them. Normally, when we subscribe, we're passing in the observer with the next, error, and complete methods. But our subject and behavior subjects also implement the iObserver pattern and have the next, error, and complete methods that we can call on them. Okay, so that gives us control over being able to emit items into our stream, being able to specify an error that we want passed along or to complete our stream. All right, so that's an action stream. So what we end up with here is productSelectedAction is our subject or behavior subject if we want an initial value, and productSelectedAction $ is the as observable that is associated with that subject or behavior subject. Okay, we're good? You guys are really awake for this hour of the day. It's amazing. All right, so our 3 steps. Our first step was to create a action stream. So that's what we just did. Our second step was to merge it with our data stream. And guess how we're going to do that? With combineLatest again. So now we have our 2 streams here. What we want to show on our right, let's see, that's the right-hand side of the page is we want to show the detail. So, and we want that detail to include the category, the actual category string, not the category number. So we're going to use our products with category stream, the one that we've already gotten that category mapped correctly for. And we're going to use our action stream, the productSelectedAction. We're going to pipe that through, and again, we are using array destructuring, so that first stream that I'm getting is going to emit an array of products, so I'm calling that products. The second stream that I have there is emitting the product ID of the product that the user clicked on, so I'm just calling that one selected product ID. Okay? All right. So the last part then, I'm doing a find on that product's array to find the particular product. Now, if I was going to be doing an edit or something, I might actually want to call an endpoint and get the most recent one. But since I'm just displaying the data instead of hitting the server again, I'm simply going to find the product that they picked in the list I've already retrieved from the server. Okay. So that was our second step. So we collected, created the action stream, we combined it with our data stream. Our last step then is we want to emit a value on an action. So in our template, when the user clicks on one of the products on the left, we're going to bind our click to onSelected. So in our component, we're going to have an onSelected method. Our template's going to pass in the ID of the one that they clicked on, and it's going to call a method in our product service. Our product service code then is going to call our subject's next method. You notice that one doesn't have the $sign on it, so that's our subject version. And we're going to call next, which basically takes that selected product ID and emits it into the stream. So here is the picture in kind of a marble diagram-ish kind of way. So our first stream there is our one and done data stream. That's our list of products that we're getting. The second stream represents our action stream. So the user clicked on the one. We don't get anything emitted from our combineLatest until both of them have emitted something, which is why you might want to use a behavior subject if you want it to be able to start with an existing value. Then it emits the combination of those two things. When the user picks something else, it re-emits. And what happens when it re-emits is it re-executes your entire pipeline. So next time that product selected action emits something else, it reruns your pipeline and refines the new product, and since it's all bound to the, it's set in the component, bound in the template, it's going to have change detection automatically, have it display the new product. Okay, so all we are doing in our code is when the user clicks on something, we're throwing something into the stream, and everything else handles itself. Okay, we don't have to tell, oh, I need to tell this that it changed or that it changed or whatever. Okay, caching. Now, if we just have our system as we've defined it so far, when the user clicks on product list, it's going to do our binding to our observable, which is going to kick it off, and it's going to go get our data. If the user then goes to the home page, it's going to destroy the page, which loses all of our data. If they click on product list again, it's going to go back to the server and get our data again. Now, if you have a highly transactional system, that might be really desirable, but maybe in our company, our product line only changes once a month, once a quarter. We don't need to be getting the data every couple of minutes as the user moves around. So how do we deal with that? Well, in the old days, like yesterday, we might have cached that in our service, because if it's data cached in the service, we can easily share it. But now that we have everything in these streams, we can use the share replay operator. So the share replay operator takes our data that we've retrieved. So here it'll be our product data that we've retrieved, and it puts it into a replay buffer. So even if the user leaves the page, when it comes back, it resubscribes and it replays, and I have a replay of 1, so it will replay that last emission, which is the data that we had retrieved. So it remains active even though if there are no current subscribers, which will be the case if you go to the home page. So a really handy little operator. Okay, so the last thing that I have is to observable all the things. Okay, what do I mean by that? All right, so our right-hand page has not only our product data and our category, it also has our supplier data, and it has that title on the top. Notice that title also has the product information as to which product is there. So that means we have to have some kind of code to update that every time that the product changes. How do we do that? Well, in our component, we can simply use product dollar, because now we're on the right-hand side. That's the detail. It's the one product. We can assign that to the selected product that we've already figured out from our action stream combined with our category stream. And so we've got our product dollar all set, all ready to go to bind to show our product data with its category. We can also take our page title and we can make that an observable. We can take our product stream and use the map to transform a product into a simple string. Okay, so that's going to be our page title, and every time this .product is modified, which will occur every time selected product changes, which occurs every time something emits into that action stream, it will automatically change our page title and product dollar, our selected product that we've displayed. And then, of course, we've got our product suppliers coming from our product service, where we used our mergeMap to get the data. I have the full code for this in my GitHub, and I'll have the link at the end. Okay, so now you have all of this. So we're going to merge our streams, all of the streams that we need for our user interface, because we don't want to have 16 async pipes in our template. We want one. So we're going to merge all of our streams together. And again, thanks to Xander for showing me this technique that I then stole and I'm presenting to you all. So here is the combineLatest, where I'm showing combining three things. We've got our product stream, we've got our product supplier stream, we've got our page title stream. Depending upon how much else we're showing in this UI, we can have more streams here. Then I'm piping that through. The first thing I'm doing is filtering for a null product. That way it doesn't try to display anything if nothing's been picked yet. Because in our application, when the app first comes up, nothing's picked. We don't want it to try to display anything. If there is a product, what I'm doing is, again, using array destructuring, assigning a variable name to the result of each of the streams, and then I am basically transforming that array with named elements into an object. Now, why am I doing that? Because it's a whole lot easier to work with objects in our template than array elements, again, with the bracket 0, bracket 1, what do those mean? So here I'm creating an object from my array. Then in my template, I have one async pipe, piping to this VM, async as VM, and then I'm just accessing these properties, vm.pagetitle, vm.product, vm.product suppliers. That VM is kind of a kickback to the old Angular 1, right? Remember that? Yeah. So it's sort of lovingly remembering. So what do we think? Is this something worth trying? Yeah? What do we think? Like that? Okay. So there are some cons, of course, to this approach. Picking the right operator is sometimes not easy, difficult to debug, but there's a lot of benefits as well. All right, so with that, here's the link to my slides, my code, and feel free to follow me on Twitter. And thank you all very much for coming. I appreciate you staying this late with me. Thank you.